Okay, so vapor pressure of solutions. We had vapor pressure of pure solvents. Now we have vapor pressure of solutions. And they are going to be different because a non-volatile solute, something that won't vaporize, is going to lower the vapor pressure of the solvent. So I'm going to draw you another horrible picture. Okay, so there's our liquid. It's got a lid. Okay, so if it's just the pure liquid, well, everything at the surface can vaporize. Now, we have our liquid, and again, it's got a lid on it. And now we put some solute in it. There's solute at the surface, preventing solvent from vaporizing. So we have Raoult's law. The pressure of the solution is equal to the mole fraction of the solvent times the pressure of the pure solvent. So it makes sense if the solution is 90% solvent, then the pressure is 90% of what the pure solvent would be. If it's 10%, it's not really solvent anymore, but you get the idea. Now, this is a linear relationship. Remember, we love things that are linear. So we've got y equals mx plus b, where the pressure of the solution is your y, the mole fraction is your x, and your slope is the pressure of the pure solvent. So, the normal boiling point of diethyl ether is 34.5 degrees Celsius. A solution containing a non-volatile solute dissolved in diethyl ether has a vapor pressure of 698 torr at 300 and, well, the same temperature. We don't need temperature. Okay. What is the mole fraction of diethyl ether? Well, the solution has a vapor pressure of 698. So we have this. So 698 torr is this. Mole fraction is our unknown. And the pressure of a pure solvent, we need to look up in a chart. Okay, so I looked at this question and went looking for a chart, which there is no chart in your book. So I reread the question, and I felt kind of silly because it told us the pressure right there. If it's the normal boiling point, what's the pressure? 1 atmosphere. We need it in torr. That makes it 760. So we're not going to be looking up the pressure of the solvent. It's usually going to be given in the problem. But it might be given in a slightly hidden manner. So divide this by 760 torr. Whoa, I brought up the wrong thing. There we go. 698 divided by 760 gives us a mole fraction of 0.918. And remember, there are no units on mole fraction. So we can also do a problem with water. And notice with this, the vapor pressure of the pure water is given to us. So we have pressure of the solution equals the mole fraction of the solvent times the pressure of the pure solvent. So this is the one we're trying to find. The pressure of the solvent is given to us. So we need the mole fraction of the solvent. So we need the mole fraction of water. So we need moles of water over the total moles. So 175 grams times 1 mole over 18.02 grams is going to give us the moles of water. So that is 9.71. So then the bottom is going to be 9.71 plus something else. So we have 35 grams of our sodium sulfate. We need our molar mass of sodium sulfate. 22.99 times 2 for the sodiums, plus 32.06 for the sulfur, plus 64 for the 4 oxygens, so 142.02. So we have 35. We need to divide by it, so we can do second function answer. And we know we have 0.246 moles. So 9.71 is divided by 9.71 plus 0.246. So that gives us a mole fraction of 0.975. And we've got to multiply that. If you just hit multiply, then the answer from the last line is already popped up onto the screen. 23.76. And we know that our pressure is 23.2. And it will be torr. Now, we could use vapor pressure lowering to determine molar mass, because if we have the mole fraction, we can get the moles. If we have the moles, we can get the molar mass.